third one is the solid oxide. In industry, in green hydrogen industry, mostly two type of electrolyzer we are using, PEM and alkaline. PEM is the latest technology. Alkaline is the oldest technology. Uh, I'm coming on both PEM and alkaline. And solid oxide is basically theoretically this technology is available, but practically in industry, if you see na, so none of manufacturers you can find those manufacturers are manufacturing solid oxide type of electrolyzer. So whatever manufacturers are available, they are producing either PM or alkaline type of electrolyzer. Now, first I'm going to discuss PM type of electrolyzer. So in PM type electrolyzer, polymer electrolyte membrane, this is the full name of PM. Basically, in electrolyzer, we have a one cathode terminal and then we have a anode terminal. And between cathode and anode, we have a electrolyte. Okay, so this is the basically electrolyte, and you can say this is the your cathode terminal and this is the your anode terminal. Okay, sorry, this is the cathode terminal and this is the anode terminal and this is the electrolyte. Okay, so here in PM type of electrolyte, your this electrolyte is constructed from your platinum crystals. Okay, and in this crystal you are find the some polymer membranes inside this crystal. Okay, then you have a some other material. It's depend on manufacturers to manufacturers what type of crystals they are using. So mostly platinum they are using as a crystals, and then they have a polymer membranes. And this is the your anode terminal and this is the your cathode terminal. So water basically enter in your PM through a anode terminal, and then here we have a DC source, basically electricity supply between anode and cathode terminal. Then your H2 has a reaction at anode terminal. So then from here, what happened? Your H2O is splitted in two parts. So your oxygen is coming out through your anode plates. Okay. And your hydrogen is going to cross your platinum crystals membranes and coming out from your cathode plates. Okay, so if you see, this is the basically just a theoretical representation of your PM type electrolyzer. Practically, if you want to see now, so practically like that your PM type electrolyzers look like. Means this plate is your anode, this plate is your cathode. Between two plate anode and cathode, we have electrolyte, and this is basically platinum crystals. And between platinum crystal, there is a membrane. Okay, so this is the theoretically, and through reaction you can understand the water is coming on your anode terminal, and then it has a DC source of power. So then water has a reaction with DC power. So water molecules are splitted in oxygen molecular and hydrogen. So hydrogen molecules through a platinum crystals coming on your cathode plates and then coming out, and through your anodes oxygen is coming out. Okay, so this is the theoretically representation. Practically when you see na PM type electrolyzer, so if you see this, if you see na this, just wait. You are seeing na Satya and John, what you have idea of a solar PV power plant? Do you have idea of solar PV power plant?
Yeah, just an idea.
Okay, basic idea you have, basic idea
Yes,
of
sir, just
solar
the
PV power
basic.
plant.
Yeah.
Okay, so it's good. So if you see a solar PV power plant, so your panels are basically size is very small, means panels produce the few watt of powers. Then what we are doing, then we are combining numbers of PV panel so that we have a desired size of your PV plant. Desired size of PV plant means desired watt size of PV plant, right? Means if you want to produce the few megawatt power, few kilowatt power from your solar PV. So what we are doing, we are combining the numbers of small size of PV modules in series and parallel, and then we have a desired size. Same thing with here, our electrolyzer in green technology, green hydrogen plants. If you see now, this is the basically your electrolyzer. Just see.
Sir, your voice is breaking a lot.
Still my voice is breaking.
Um, there is, it's not
Yes, sir.
break
In
basically. I mean, there
between
is some gap.
lag.
Okay. Now again it's problem. I think my network is okay.
Um, sometimes it is coming. I mean, as you talk now,
Okay.
not there, but yeah, sometimes.
So you just see here, this is the basically your electrolyzer. This is PM type electrolyzers. This is PM type electrolyzer. So these electrolyzers size are very small. Okay. So if you want to produce bulk amount of hydrogen, okay. So what actually we are doing? We are installing numbers of electrolyzers like that. If you see the numbers of electrolyzers are here installed. Okay. So this serial number one line item you are seeing that these are the numbers of electrolyzers we are installing. Each electrolyzer has some production capacity that I'm going to guide you next slide. Okay. Then what you are seeing second number, this you see na? So this is the basically complete control and monitoring a station of your entire plant. This second number. Okay. Third one is the called compressor area. Compressor unit. Compressor unit means I have already told to you hydrogen we can basically we are storing at some pressure value. Okay. So entire hydrogen means whatever hydrogen we are producing from these electrolyzers. So their transportation in these pipings and then a storage in its tank. So these entire things we are doing with help of compressor system. Okay. This fourth one is also a part of this compressor system. Fifth one is again there is a part of pressure release system. Sixth one is your hydrogen storage tank. Seven number is your oxygen storage tank. Okay. And then eight one is eight one. This is the basically your rectifiers area. So what is rectifier? I'm explaining you. So this is the rectifier and this system if you see na this system. So this system is your complete RO cleaning stations, RO filtration, yeah, basically called water treatment stations. Okay. So from this station we are getting ultra pure water. Okay, ultra pure water is something different that I'm going to discuss in coming session. Not like our RO water, yeah, clean water. This is the ultra pure water. Okay. So if I talk about any electrolyzers component, so major component first of your electrolyzer is this electrolyzer, this is a small component. Then it's control system, control area. Then it's compressor system, then a storage tank, oxygen and hydrogen, then water treatment area. And then we have a rectifiers area. Rectifier means basically this is the one electrical component, and these rectifiers are converting your AC source of power in DC source of power because your electrolyzers require DC source of power. And from your grid, what type of power we are getting? We are getting AC power. So those AC powers are coming in this rectifier area. So if you see the rectifier area as a transformer, and then it's as a rectifier. Okay. So first AC power is coming, medium voltage AC power 11 kV or 22 kV power are coming on this rectifier transformer, and then from this transformer low voltage power approx 415 volt power is going on rectifiers, and then rectifiers convert the AC power in DC power, and these DC powers are going on your electrolyzers. Got it? So just basic concept first you understand what is the actual major component, what power we require for your PM type electrolyzer. If you want to buy any PM type of electrolyzer, yeah, if you see PM type electrolyzers are their technical parameters. So you can see it, some models PM type electrolyzer, their parameter here I have shown. So just see, let's take example. We have a two model of PM type electrolyzer, M2000, M3000. Okay, and these are their technical parameters. So if you see their technical parameter, first one is net production rate. Net production rate means whatever model is here, this model, how much hydrogen they are going to produce. Okay, so if you see now, Newton cubic meter per hour. Newton cubic meter is just a one unit for your you can say hydrogen at some pressure value. Okay, so 1 Newton cubic meter means your 1000 liter. 1 Newton cubic meter means 1000 liter. So for example, if you see here, let's say take example of M3000 model. So this model, how much hydrogen they are going to produce per hour? 2.952 Newton per cubic meter per hour. Okay, so this much of hydrogen this model is going to be produced per hour. Now its production capacity dynamic range means this equipment, this electrolyzer can work at 10% to 100% load variations. Okay, means at the time if you want to produce at low amount of hydrogen, means their capacity is 2.952 Newton per cubic meter per hour. But if you want to produce only 10% of its capacity, or you want to run this equipment at 80% loading, 70% means it's run at dynamic range 10 to 100. Now next one is the power consumptions. So what is the power consumption? 4.5 watt WH, kilowatt WH. kWh is the unit of energy. kWh, kilowatt hour is the unit of energy. So approx 4.5 unit required for a 1 Newton cubic meter of hydrogen production. Okay, so this is the power consumptions. Then how pure basically your
Sir,
hydrogen
sir, just
yeah.
going going back to the second one, kg per 24 hours, it shows
Mhm.
6.371 kg per 24 hours. It is not
Mhm.
directly proportional, isn't it? Like
Sorry.
2.952 Newton.
Once again, repeat.
No, the first row which shows that 2.952 Newton cubic meter per hour, that is per
Right.
hour, and which is equivalent
Mhm.
to something like
This is not. This is not. Basically, this is equivalent to your 2900 liter of hydrogen per hour.
yeah,
Okay,
yeah.
900 liter of hydrogen per hour. Now this is not basically if you go kg per 24 hour. This is not kg per 24 hour. This is basically your plant if you want to run for a 24-hour continuously. So per hour, this much of kg hydrogen they are going to produce in form of kg. If you see now, hydrogen weight versus hydrogen volume. So there is a huge variation. It's not like your water. 1 liter water is approx 990 gram. Not like that with hydrogen. So their volume is huge. Their weight is very less. Got it? What I'm telling you.
Yeah, yeah.
So that is the, if you see in form of kg. So it's produced 6.371 kg per hour. Means this is the average rate for a 24 hour. If you want to run 24 hour, so this is their average rate. Okay. This is the not here by mistake written 24. This is the 6.374 kg per hour you can mention. Okay.
Okay, okay, yeah,
Now got it?
got it, got
Now,
it.
now I'm coming on its purity means ki how pure hydrogen or oxygen we will going to get from this electrolyzer. So approx 99.99% pure hydrogen you are going to get. Okay. If you see in this model, O2 content in hydrogen, whatever hydrogen they are producing, that is less than 1 ppm. Water content in hydrogen, this is less than 5. At what pressure value, at what pressure value hydrogen is coming out from this electrolyzer, that is 30 bar. And I have already told you the hydrogen we can store inside the tank at 60 pressure value, and that pressure value is approx 60 to 70 bar. So this gas is coming out from an electrolyzer at 30 bar, but for a whatever hydrogen produced from this electrolyzer, so their transportation inside the pipe and piping network, and then a storage of hydrogen inside the tank, we require pressure 60-70 bar. So 60 to 70 bar, that pressure value we are maintaining with help of compressor system. This compressor system we are add from this electrolyzer, hydrogen is coming out at 30 bar, but at 30 bar pressure we cannot transport the hydrogen in this entire piping network, or we can't store the hydrogen inside the tank. So for those we require entire this compression network. So with help of this compression network, we are maintaining the pressure value up to 60-70 bar, and then transporting the entire hydrogen inside this network, and finally reach the hydrogen in your tank and store for some time. Then its dimension. So its dimension of these models are depending on its configurations, then operating temperature, and then what type of electrolyte here used. So here PM type of electrolyte use. Electrolyte means electrolyte means this inside between cathode and anode and cathode. So whatever this crystal we are using, this is the called electrolyte. So this electrolyte is PM. So this is a major parameter of your any electrolyzer. So from this major technical parameter, you can easily understand कि whatever model you are choosing, whatever model of electrolyzer you are choosing, so that electrolyzer, how much hydrogen they are going to produce, how much power they are going to be consumed, right? So this is the basically major component of your electrolyzer. One thing just keep in mind, कि for example, if you think any green hydrogen plant size, basically we are defining in form of volume or in form of kg. This much of hydrogen plant I'm going to install, yeah, this liter hydrogen plant, yeah, this kg hydrogen plant we are going to install. So green hydrogen plant size we are not defining in form of kg or liter. Green hydrogen plant size we are defining in basically unit, basically you can say megawatt power unit. Just like a data centers, you know, na data centers we are using to store the data. So if you see any data center, na data centers size or their data centers unit is not like that ki how GB, how many GB, yeah, what amount of data they are storing. Their size is defined, their data center size is basically we are deciding ki how much power they are going to be consumed. So data center size always defined in megawatt. 100 megawatt data center, 50 megawatt data center, 200 megawatt center data center. That means ki how much power they are going to be consumed to run the entire data centers. Okay, so same thing with your green hydrogen plants. So green hydrogen plant size now we are defining like that: 200 megawatt green hydrogen plant, 50 megawatt green hydrogen plant, 20 megawatt green hydrogen plant, 100 megawatt green hydrogen plants. So that means there whatever electrolyzer you are installing in that particular 20 megawatt green hydrogen plants, 20 megawatt green hydrogen plant means there whatever electrolyzer you are installing, they are consuming how much power? 20 megawatt. If I'm talking about 50 megawatt green hydrogen plant, so 50 megawatt green hydrogen plant means there whatever electrolyzer I have installed, so those electrolyzers are consuming 50 megawatt power. Got it, Anand and John? What actually I'm telling? So green hydrogen plant unit is basically plant size. You can say we are defining in megawatt scale, not in you can say hydrogen volume or hydrogen weight. We are defining green hydrogen plant size in power consumption, you can say rating in megawatt scale. What megawatt scale of electrolyzer you are going to install in green hydrogen plant? Got it what I'm explaining?
Sir, just one thing.
Yes, sir.
Here, when we are saying it as megawatt as a capacity, I mean we do have that generation capacity also, no? Hydrogen. How much hydrogen will be generated out of, let's say, 100 megawatt hydrogen plant?
Just see here, why I'm talking about. Just see here, 4.5 unit power required for a per Newton cubic meter. You see here, na?
Yeah.
Just see. Okay. So for example, if I convert this in megawatt, so what I'm going to do, multiply by 10 power 3. So if I'm talking about 4.5 megawatt, so 4.5 megawatt size of electrolyzer means how much hydrogen they are going to produce per hour. So 1000 Newton cubic meter, because 4.5 megawatt power required for 1000 Newton cubic meter of hydrogen, means 4.5 kilowatt here required per Newton cubic meter. So for a 1000 Newton cubic meter, how much power required? 4.5 megawatt. Got it?
Yeah.
Anand, you got it or not? John,
Yes,
you
sir.
understand? John,
Yes, sir. Yes, sir.
you
Understood,
got
sir.
it? How
Yes, sir. Yes.
how okay, good. Okay, so this is the PM model. Okay. Now, second model we have, second type of electrolyzer we have, that is called alkaline electrolyzer. Okay.
Sir,
And
just
alkaline,
sorry, sir. Just one more thing. You the last row was showing proton exchange membrane, but in the previous slide you said polymer electrolyte membrane. Both are same.
both are same. Basically, their technical word, actual technical word of electrolyte is proton. Okay.
Mhm.
But if you go in market as a commercial scale, yeah, industrial scale, so they are using polymer. Basically, PM is polymer. They were using polymer electrolyte member. Okay, so this is the basically common name they are using in industry. But electrolyte, their electrolyte is actual proton exchange membrane. Okay, electrolyte. But entire product is basically called as a your polymer electrolyte membrane. Okay.
Yeah.
Now, second electrolyzer is basically your alkaline type of electrolyzer. So PM type electrolyzer, na, a small size of PM type electrolyzers are available. You just say, if you have an idea of solar PV power plant, So in solar PV power plant, two type of inverters we are using. One is called string inverters. So those inverter rating are very small, like that, small inverter. And second inverters we are using in PV solar power plant, that is called central inverter. So central inverter size is big size of inverters we are using. So same thing with electrolyte, same thing with this green hydrogen plant. Your PM type electrolyzers are a small size of electrolyzers. Okay, and this is the advanced technology. And when we talk about alkaline type of electrolyzer, so this is the big size of electrolyzers. Okay, so as of now, if you see in India and most of the European country, if you see, so they use alkaline type of electrolyzer. PM is just a new product in this technology. Earlier we are using alkaline type of electrolyzer. If I talk about my experience, so I have also used alkaline type of electrolyzer. I have not used anywhere PM type electrolyzer because this is the costlier compared to your alkaline, and also not available in big size. They are available in a small ratings. Okay, so this is the new technology, PM type electrolyzers. Lots of work are going on those technology, PM type electrolyzers. Maybe after some times we are going to see big size of PM type electrolyzers. But as of now, commercially, in big size of green hydrogen plants, we are using alkaline type of electrolyzers. So in alkaline type electrolyzer, we are using alkaline solution as a electrolyte. So alkaline solution, we have two options, either a sodium hydroxide or a potassium hydroxide. So these two liquids we are using as a electrolyte in alkaline type of electrolyzers. Okay, so in these electrolyzers again we have a cathode and we have a anode. Okay, so water in your electrolyzers through a anode. Okay, and then hydrogen out from your electrolyzer through a cathode. So you can see this is just a theoretical representation of alkaline type of electrolyzer. So if you see now this OH, so mostly we are using potassium hydroxide as a electrolyte. So as of now, whatever electrolyzers are available in case of alkaline, so they are using potassium hydroxide. Theoretically, we are talking about sodium hydroxide, but none of where sodium hydroxide we are using. We are using only potassium hydroxide as a electrolyte. So this is the your anode terminal, this is the cathode. Between anode and cathode, we are running DC power. Okay, so then there is a reaction between water at anode terminal. So then what happened? Water is split in two part, hydrogen and hydroxide. Okay, so then hydroxide coming on your anode terminal. Here again reaction. So further hydroxide is split in your O2 and then water. Okay, so if you want to see overall reaction, so at cathode you have a water, then you have a electrons. So these electrons basically from your DC powers. So due to these electrons, there is a reaction with your water. So we have a hydrogen and OH. So finally, hydroxide is going on anode terminal. Anode terminal again has a reaction. So we have a O2 and H2O. H2O is coming out and O2 is coming out. So overall reaction is H2O. Then we have H2 plus half of oxygen. So this is the reaction, overall reaction in alkaline type of electrolyzers. If you want to see the basically alkaline type of electrolyzer, so they look like that. Alkaline type of electrolyzers. So they look like a big size. Okay. this alkaline. So its technical parameter you can see here. If I talk about this model, let's take example A1000. If I talk about this model A1000, so just see here its production capacity. If you can see, approx 970 Newton cubic meter per hour. If I compare with this is 2.9, this is 2.9, and this is 970. If I going with top model of this, so they are producing approx 4,000 Newton cubic meter per hour. You just see. So alkaline type of electrolyzers are available in bulk side. You can say big size, and they are producing hydrogen in bulk amount. Okay. Then their power consumptions you can see here. Their power consumption is approx same 4.4 to 5 kWh per Newton per cubic. So their power consumption is same. There is not difference. Okay. But there is a difference with alkaline versus PM technology. Okay. So if you are going with alkaline solution, so if you have a 4.4 kWh, whatever means their electrolyzers quantity is basically reducing. Here, if you see now, here you require more numbers of electrolyzers for your desired size of plant. Okay, but here, in case of this alkaline, numbers of electrolyzer quantity is reducing. What actually I'm telling you now. Then here it's how much pure hydrogen they are producing, the same as your PM, approximately 99.99%. Then their O2 content, water content. Okay. Then its delivery pressure. You can see its pressure is high. Means this is the big size of machine. Okay, so they can deliver the whatever hydrogen they are producing. So that hydrogen coming out from this equipment at pressure value, you can see up to 200 bar. Okay, its dimension again you can see approx 350 square meter, one electrolyzers. So just see its size is very big, right? 350 square meter. Operating temperature you can see 5 to 35. Then what type of electrolyte they are using? 25% of potassium hydroxide solution. So these are the major parameters of your uh, alkaline type of electrolyzers. Okay, so this is the alkaline and PM. Mostly we are using alkaline type of electrolyzer. This is the advanced technology you can say. This is the running technology. Most of the green hydrogen plants are running on this electrolyzer, alkaline type of electrolyzer. PM type electrolyzer is latest. In my idea, I have not seen anywhere PM type. Basically, running plant I have not seen. Maybe somewhere, but none of plants in my knowledge running on PM type electrolyzers. So PM is the latest technology. Lots of work are going on PM. Lots of financial modeling is also we are working. Can be in future we use PM because there are some advantage with PM. In alkaline type of electrolyzers, we require regular maintenance. Just like if you see na, we have a one lead acid battery, and second options we have a dry battery, that is the nickel cadmium battery. So in dry battery we require very less maintenance, and our lead acid battery we require regular maintenance. After some time we are changing the acids, then cleaning the electrodes. So same thing with this. In alkaline type electrolyzers, we require lots of maintenance work. Okay, but PM we require very less maintenance. So their running cost is very less compared to alkaline. So lots of work is going on. Maybe in future project can be used or not. Lots of manufacturers are also working on their R&D part. how we can improve their production capacity, how we can improve their size. So going on, but as of now, most common use, you can say, model of electrolyzers are the alkaline type of electrolyzers. Got it, Anand and John?
Yes, sir. So just a
Yes, sir.
couple of questions here. Here in the alkaline, you don't need compressor, whereas PM requires compressor, isn't it?
Here also require compressor. What happen? If your size of plant is small, okay. So in this case, we are not using additional compressor. Okay.
Mhm.
But if our plant size is big, so in this case, what happened? Like our piping network is increasing. Okay, our tank size is increasing. So for that, we are using additional compressor. Okay, maybe when our electrolyzers maybe not deliver that much of the pressure, so we require compressor system. So for that, we are doing the complete one sizing for entire piping network. Actually, what happened? Like, as it is piping network length is increasing, so your pressure value is coming down. Okay.
Yeah.
So at tank point, how much pressure finally we are getting based on net piping network size we are deciding, and then if we require, so we are adding compressor. So mostly in a small size of plants, we are not using compressor, but in above 5 megawatt plant, we are using compressor above 5 megawatt.
Okay. Okay. Yeah. Right, sir.
Okay. Now, so this is the just a comparison between your alkaline versus PM. So this is a theoretical, not big that. This is I'm going to share with you, so you have a better idea. Now, these things you can see here. Complete one, you can say, representation of green hydrogen plants. So this is the your electrolyzer, means electrolysis. And in green hydrogen, we are using green source of energy. Therefore, this is called green hydrogen. Okay. So green source of electric energy we are using. So either from a solar PV power plant, wind farm, or hydro. Okay. And then this green source of whatever energy, that is the AC power. And that AC power we are converting with help of rectifiers in DC, and DC power finally going in your electrolysis. And from your electrolysis, means electrolyzers, we have a two product. One is oxygen and one is hydrogen, and their ratio is 1:8. So if you are producing 1 kg hydrogen, so oxygen is 8 kg. Okay. Now hydrogen we are using in our power plant. We can use in cooling towers. Hydrogen we can use in our fertilizers industry, chemicals industry, refineries, and oxygens downstream in applications, mostly in medicals, then your pharma industry, then your nowadays oxygen we are start using in your fertilizers plant, steel plants, right? So there we require oxygen. So there we are using those oxygen. This is called green oxygen. Okay. Now, this is the complete process. You can understand. This is the water purification, water treatment plant. So ultra pure water we required. One word I'm here using, ultra pure. So that I'm going to explain you what is ultra pure water. Okay. So from a water treatment plant, we are feeding in electrolyzer, ultra pure water, and at cathode terminal, and this is the anode terminal. And then here AC power is coming from grid on transformer. Transformer further step down the power voltage rating. Then we have rectifiers. Rectifiers convert the power in DC. DC power here we are feeding. Finally, we have a hydrogen and oxygen, and we are storing in tanks. Now, this is the complete This is the, you can see one typical model of your hydrogen plant. This is a typical model. So this is the solar PV modules area. Okay, and this is the your electrolyzers, a small electrolyzers plant. So it's office, hydrogen filling stations, their compressor area, electrolyzers room, and then grid room. Actually, if you want to see green hydrogen plants, so you can see here. These are the actual green hydrogen plants. So you, if you want, for example, if you have a plot plans, if you have a land, so how you can plan, where I can plan all their major components area in given plot plan. So like that you can plan. So what are the major area of any green hydrogen that you can understand from this diagram? You can see this one, for example, this is the one complete green hydrogen plant. So this is their entrance, or you can say gates. Then this is the your buildings, you can say control, their seating, so and all those main building. Okay, this is the building. Third one is the water purification, water treatment plant. Okay, so here is the water treatment. This is the major component. So this is the water treatment plant. And fourth one is the your substation, or you can say switch yard, because we require bulk amount of power, megawatt power. So megawatt powers are coming from a grid at high voltage level, 132 220 kV, and then from this grid, high voltage power are further step down in 33 kV and 11 kV. So this step down power, 33 kV or 11 kV powers are going in this area. This area you can see, these are the numbers of transformers. So these numbers of transformers, this area is called rectifier area. These area are called rectifier area. So from here power is going at 33 11 kV, and further this transformer, rectifier transformer, convert the 33 kV 11 kV powers in low voltage 440 volt, and 440 volt powers are going in rectifiers. So all rectifiers are placed inside these buildings. Okay, so inside the building you have a rectifiers. Okay, so that rectifiers what doing? They are converting the your 400 volt AC power in DC. Finally your electrolyzer is working at what power? DC. So here is the your rectifier buildings. This is the rectifier transformer area. This is the switchyard area. Okay, so now after this power is coming out, and these powers are, if you see, now this is the cables, these are the cables. Finally through the cables power is going in your, this one is the 9 number, if you see, sorry, 8 numbers, 8 number, this one. If you see this 8 number, this is the basically your complete electrolyzer building. This is the electrolyzers. Inside the this building is the numbers of electrolyzer. So from here power is going here, and this is the piping network. So piping network of your water supply, you just say here, from here with help of pipe racks, water is going. Okay, so water is going in your electrolyzer. So this is the piping. Again, from this electrolyzers piping is coming out. So some of pipe are for your hydrogen, some of pipe for your oxygens. So this is the complete piping network area. Okay, this one 6 7 8 9, if you see. Okay, and this 9 one is the compressor area. So inside this building you have a entire compressor, motors, pump. Those are maintaining the pressure value of your entire piping network. Either it's a water pipes, either your oxygen pipe, hydrogen pipe. So 9 numbers is compressor area. Okay, 10 numbers of purifications area. Okay, then your 11 number hydrogen storage tanks. This one. Okay, then here is the heat integrated, but nowadays we don't require. Nowadays whatever electrolyzers is coming, they don't need any cooling towers, any heat integrated system. Only we require oxygens. Earlier days we require, but nowadays this is not applicable. Okay, so these are the your you can plan these like that. You can plan for any layout. If you have some plot plan, in plot plan you want how I can plan the entire green hydrogen plant. So like that you can plan. You can plan some of area for your switch yard, some of the area for your main building, then some of area for water treatment plant, then some of area for your rectifier area. There you have a rectifiers and transformers. Then some of area for compressor system, rectifiers building, piping network, and then hydrogen storage and oxygen. Like that you can plan for any green hydrogen plant. So these are the major area you have to think and you have to plan. Got it?
Sir,
Yeah,
I have a doubt.
yeah, tell
Sir,
me.
this purification system is for H2 purification, sir.
This one is the for H2.
Sir, but the electrolyzer already
Actually,
output H2 is
right, right,
99.9.